Great afternoon, morning, evening, mini mathematicians. So happy you can be here. I'm on page 35. I hope you're on page 35 also. And let's track the title together. 6.2a lesson, comparing the perimeter and area of polygons. And I want to remind us that a perimeter is all the distance, the length, if you walked all the way around or if we built a fence. Where area is all the space on the inside. Perimeter is one dimension, where area is two dimensions. And that's really important because they have different units when we're working through here. Let's look at activity 1. Below is an image of rectangle ABCD with dimensions of 4 units by 6 units. On the first grid provided, draw a rectangle with side lengths twice as long as this image. And the new vertices are going to be E, F, G, H. So we're still going to have a rectangle. It's going to be rectangle EFGH where the side lengths are twice as long. And we're going to be focusing on something more than just counting. We're going to see if we can do more than just counting, because I'll tell you counting 8 little squares and 12 little squares twice can be a little nerve-wracking. I sometimes make mistakes. And then what about this on this other grid? And on the other grid, draw a rectangle with side lengths that are half as long as this image. And our new vertices are going to be I, J, K, L. So remember, this is going to be half the length, and this one is going to be double or twice the length. Awesome. Well, let's get started. Sides that are twice as long as the image above. Notice that E corresponds with A. So EF, the length EF, is going to correspond with length of AB. So that means AB to C is going to correspond with EF to G. To move from A to C, I go to the right 4 and up 6. Right 4 and up 6. So to move from E to G, if I'm doubling all my distances, I'm going to go from point E. I'm going to go from point E to the right. How many? How many will I go right if before I went right 4? Well, twice is to go right 8. Excellent. So let's go right 8, or you can go right 4 times twice. 1, 2, 3, 4. And then another 1, 2, 3, 4. And that will bring us to vertex F. And you can use your protractor, straight edge, or ruler to draw that really nice line. So if I went right 8, now I need to go up. Before we went up 6, so we're going to go up 12. Or you can count by going up 6 twice. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This vertex will be vertex G. Once I have 2 sides of my rectangle, I can draw the other 2 sides because I know that they are congruent. Congruent means like cookie cutters. They're exactly the same. So I'll put in that vertex, and that should be vertex H. And we can double check we're right because we should go, if we went from B to D, we'd go up 6 and left 4. So we should go up 12 and left 6. 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5. Oh, sorry, over 8. 6, 7, 8. This is 8 units, and this is 12 units. Awesome. Let's look at 1. Describe the method you used to double the length of each side. Well, maybe what you did was you counted, and then you counted over and doubled. I did something a little bit different, and I'd like you to think about the method that we use today because we're going to be using that method to make more connections later in the lesson. So how did we move? Well, I noticed that point A to point C was right 4 and up 6. Point A to point C was right 4 and up 6. Hence, to double the lengths, to move from point G to, point E to point G. When we move from point E to point G up above, we moved right 8 and up 12. I guess we could say units if we wanted to. Units. Nice job. Well, let's go and talk about our other grid when we half the distances. Well, before, to move from A to B, we went right 4 up 6. So if we half the distances, when we start at vertex I, because I corresponds with A, J corresponds with B, half of 4 is 2, so I'm going to go right 2, and I'm going to go up 3. So I, J, K. And just copy that pattern to find L. Nice. So what's the method that we use to half the lengths? From point, where do we start? I to K. From point I to point K, move right 2, which is half of 4, and up 3, which is half of 6. Nice, excellent job. Part 3. Do you think the area of the new rectangles change at the same rate as the sides? Explain. So what did our sides change as? Our sides changed at a rate of 2 and a rate of 1/2. So is our new area of our rectangle EFGH twice the area of our original rectangle? And is our new rectangle IJKL half the area of our original rectangle? Well, let's take a look. If you were to count up all these squares to find the area of our original rectangle, what would you find? Take a moment to think about that. The area of our original rectangle is a 6 by 4, and if you counted all these up, you'd have 6 groups of 4, 4 groups of 6, so you'd have 24 square units. And if we look at our big rectangle that we doubled, what would that area be? If we counted up all these blocks, we'd have 12 groups of 8 blocks, or if we went this way, 8 groups of 12 blocks. What's 8 times 12? Well, that's 96 units squared. And then our final rectangle, remember that this is a 3 by 2, and we could count all the little squares or think about 2 groups of 3 or 3 groups of 2, and we end up with 6 units squared. So is 96 double of 24? No, it's not. And is 6 half of 24? It's definitely not. So I wonder how areas and side lengths compare. So let's look at number 3. Do you think the area of the new rectangles change at the same rate as the sides? No. We just saw that above. No. Area, and this is because area is squared. Notice our units were units squared. And that means 2 dimensions. Perimeter and side lengths are only one dimension. So what do we think we notice happens when our side lengths are doubled, 6 to 12? What happened to our area? What do you multiply 24 by to get to 96? What do you multiply 24 by to get to 96? What do you multiply 24 by to get to 96? Well, we're going to answer that question by filling in the table below. So let's take a look. These are our different rectangles. These are asking what the dimensions are. So let's see. Rectangles are different rectangles. Rectangle EFGH. Rectangle EFGH was an 8 by 12. And the perimeter, if we added up all the sides, that's going to be 12 plus 12 plus 8 plus 8, which gets us what if we added up all the sides? Oh, you know what another good way to think about perimeter is twice one side plus twice the other side. That's another way. So 2 times 12 plus 2 times 8 is another way you can think of perimeter. Is there another way to think of perimeter? Oh, you can just think about twice and then 12 plus 8. Overall, no matter how you do this, you end up with 40. And what was the area of our big rectangle? Well, that would be 8 times 12, which we said is 96. And notice we have our units squared here. Notice we have our units squared in our chart that we're filling out. So what was the change in the side lengths from the original rectangle? We doubled. So what was the change in the perimeter from the original? So notice our first row is all the original. So from our original perimeter 20 to 40, oh, how did our perimeter change? Oh, our perimeter doubled also from our original. Interesting. And let's look at our last column. It says change in area from original rectangle. Well, we went from 24 to 96. What do you multiply 24 by to get to 96? 4. Wow, so this was quadrupled. Quadrupled. Or we can say times 4. And here, doubled, we can say times 2. How do you go from 2 to 4? That's interesting. Okay, well, let's look at our other rectangle, our smaller rectangle, rectangle IJKL. We saw that those dimensions, what were the side lengths of IJKL again? That's right, this was a 2 by 3. Perimeter, if we added up all the sides, what will that be? 2 plus 2 plus 3 plus 3. 4 plus 6 will get you 10. Good job. And what's the area? Length times width for a rectangle. So 3 times 2 is, that's right, 6. So we want to look in the change in the lengths from the original. Do you remember how we changed the lengths of rectangle IJKL? We halved them. So this was half the original. So let's look at how their perimeters compared. So here's the perimeter of our new rectangle 10, and here's the perimeter of our original rectangle 20. How would we go from 20 to 10? Oh, it's also half. Half the original. Okay, let's look at our last column. Change in area from original rectangle. Well, remember, the original rectangle is our very first row. So 24 to 6.